Relative velocity, type 2, wind appears to blow. So in 2010 we had a motorcyclist travelling a straight road from south to north at a constant speed of 12.5 metres per second, and the wind appears to come from a direction of 45 degrees north of east. When returning along the same road at the same constant speed, the wind appears to come from a direction of south 45 degrees east. So in these questions we basically have two cases that allow us then to find the magnitude and direction of the velocity of the wind. So it's important to note there that we have to do magnitude and direction for our answer, and it's the wind that we're looking for. So we're going to start by setting up our two cases. We're going to have two diagrams for case 1 and then for case 2. So I'll do case 1 first of all. So normally I would do these side by side, but for the purpose of this video, I'm going to do them one by one. So we're going to set up our little diagram and our mariner's compass to show us which way the wind is appearing to come from and which way the woman is going. So we're told in case 1, so I'll mark here on the question, case 1 versus case 2. So in case 1, we have the wind appears to come from a direction of 45 degrees north of east. So it's coming from that direction, and it's 45 degrees north of east. We then have the motorcyclist is travelling along the straight road from south to north at a speed of 12.5 metres per second. So this is the direction that the motorcyclist, I keep saying woman, the direction in which the motorcyclist is going. Right, so we have the wind and we have the motorcyclist. And the speed at which she's travelling is 12.5 metres per second. Okay, so we're going to let the velocity of the wind equal xi plus yj, and we're basically going to be trying to find out what is the value of x and what is the value of y. So what do we know? Well, we know that the velocity of the motorcyclist is 12.5 in the j direction, and that's meters per second. And we then have the velocity of the wind we're calling xi plus yj. Again, that's in meters per second. And therefore, if we're looking for the velocity of the wind relative to the motorcyclist, well, then that's going to be the velocity of the wind minus the velocity of the motorcyclist. And again, that's page 50 in our maths tables. So therefore, if I sub in, what does that give me? Well, the velocity of the wind we're saying is xi plus yj minus the velocity of the motorcyclist, which is 12.5 j. So if I group my i's and my j's there, that gives me the velocity of the wind relative to the motorcyclist is xi plus y minus 12.5 in the j direction. However, we know that the wind appears to blow from the northeast. So that gives me my direction that it appears to come from. So in other words, that gives me my slope. In other words, my tan is my j over my I, so my opposite over my adjacent. And that direction is 45 degrees north of east. So therefore, my j vector is my y minus 12.5 over my I vector, which is x, and tan 45 we love because that's just 1. So if I cross multiply there, I get x is equal to y minus 12.5. So that gives me one equation for my first case. So I'm now going to repeat this for case 2. So if we go back up to the start, well, we have case 2 is when she returns along the same road at the same constant speed So this time she's basically going from north down to south as opposed to from south to north. And then this time the wind appears to come from a direction of south 45 degrees of east. So on the next slide we'll just do case 2 setup. So we'll draw again our diagram. So we'll do our little mariner's compass. So the motorcyclist is now coming in the opposite direction, so she's returning. Her speed is still going to be the same. So that's still going to be 12.5 meters per second. This time the wind appears to come from the southeast. And that's at an angle of south 45 degrees east. So we always have to be careful that we're putting in the angle in the right position with respect to the information given to us in the question. So it could be with respect to the y-axis or it could be with respect to the x-axis, and that can make all the difference in your answers and your solutions. So what do we know? Well, we know that the velocity of the motorcyclist is this time going to be 0I minus 12.5j because we're going in a downward direction. The velocity of the wind, we've already established that we're going to let that be xi plus yj in meters per second. So the velocity of the wind relative to the motorcyclist is vw minus vm. And then if we sub into that, well, what does that give us? Well, that gives us xi plus yj minus the velocity of the motorcyclist, so it's minus 12.5j. And again, if I group my i's and my j's there, well, that gives me xi plus y plus 12.5j. So again, we know this time that the wind appears to blow from the southeast. So again, if I'm looking at direction or slope, well, that's tan is your opposite over your adjacent, so it's j over I. So of course, if I look at that angle with respect to our unit circle, well, what angle have we got? Well, if I go all the way around, that's basically 315 degrees. So 45 degrees in the fourth quadrant there. So it's 315 degrees. And again, opposite is y plus 12.5 over adjacent, which is x. Well, what's tan of 315? Well, it's minus 1. And that's equal to y plus 12.5 over x. So if I cross multiply, I get minus x equals y plus 12.5, or x is equal to minus y minus 12.5. So I've written them as x equals, so I'm just going to equate the two x's, or you could set it up so you have your x and your y and your normal simultaneous equation. So by equating the two of these, or as I said, solve as normal, well, what do I have? Well, we said that x was equal to y minus 12.5 for 1. And then we said x is equal to minus y minus 12.5 in 2. So by bringing all the y's to the left-hand side, well, what does that give me? It gives me 2y is equal to 0. So in other words, y is 0. So then if I sub y into equation 1, well, what does that give me? Well, it gives me x is equal to 0 minus 12.5. So x is minus 12.5. So therefore that tells me then that the velocity of the wind, which is x plus y, xi plus yj, is going to be minus 12.5i plus 0j. Well, what does that tell me? Well, it tells me that the magnitude must be square root of a squared plus b squared. Now, we can obviously see that the magnitude is going to be 12.5, but just for the sake of writing it out like we normally would do in other equations. We have minus 12.5 squared plus 0 squared, which gives us the magnitude of the wind's velocity is 12.5 meters per second. And of course then, what's its direction? Well, I can clearly see the direction is only in the I direction, and it's in the negative I direction. In other words, the direction is west. Okay, so where were we getting our marks from? Well, again, we had 30 marks for this question. And again, you might have an alternative way of setting up your question, or a different way of doing it. But our marks were basically going to end up getting two simultaneous equations for the two velocities of the wind relative to the motorcyclist for the two different cases. So we had 5, and then getting our slope is going to be another 5. And then the same for the next one, setting it up. We had 5, and getting our equation, we had 5. And then solving for our velocity of the wind, so for our x and our y values, we were getting 5. And then 5 for getting the magnitude and the direction. So 30 marks in total.